we'll speak about RAG. So I'm co-founder of Hymalaia. We are a factory of agent, and we will see how we can connect data inside agent. So first, a screenshot of the product, Hymalaia. Here, I ask to an agent what I should know about BBC. I'm a sales, and I have plenty information everywhere on my system, on my CRM, on my ERP, etc. And I want to have a sum up, a 360 view of my customer. So this is an agent built for that. And what he will do, he will look about several sources, like Notion. He will create some minute of the last meetings on my mailbox, on my Salesforce, all the opportunity, and be able, let's say, to give me some data with you see some link, some hyperlink, so I can see the raw data to be sure there is no hallucination, and that's really my data. And to do that, in fact, so when you want to do that, first we have an issue is we have more and more documents. We have millions of documents we should index, and the agent should know. And LLM right now alone, without any system, a lack of reliability, where companies expect trust, relevance, and traceability. So first solution is to create a simple RAG. It's very easy. It's a half day of dev, but it's not working. It's connect LLM to document database, but it's too basic and poor accuracy. And here we will see several ways, let's say, to do advanced RAG that can manage massive data, that can manage structured and unstructured data, and without hallucination, to have a trusted tools. So let's see with a first workflow for indexing. So on the left, we have several sources. And when we want to index these sourcings on the data store, we will split the data and we'll have some chunk. The issue with chunking is the size of the chunk. If the chunk is too large, we will lose detail. Is too small, we lose context. What we will do at Hymalaia is we have multipass indexing, and it's how it can increase, let's say, the accuracy of your search. So that means the same data, the same document will be indexed several times on the data store with large and mini chunk to get both context and detail. So when we will use that, so when the user will ask a question, for example, what do you know about BBC? We will embed the question and do vector similarity search on the data store to get all the relevant chunk, all the relevant document, and give that to the LLM to have the answer, to write the answer with our own document. That's good, but that doesn't work well when you have something that is not, when the question is not exactly the same that your document. When you have different language, different business glossaries that are not the same in the document on the question. So what you can do is add other algorithm to do several ways of searching. Here we had also a BM25 with a keyword search. So that means we will be able to extract some keyword from the question of the user and look at some information on the system based on this keyword. So we'll have several output, and at the end we'll normalize, do some score adjustment, do some re-ranking to have the good document from the company. That's good, but that's not enough. Sometimes you have big question, and what you need, in fact, is to split this question and to run several agents in parallel that will answer part of the question. Here, for example, I want to know all information about BBC. The agent will decide, okay, I will first ask what are the pain at BBC, what are the equipment deployed at BBC, what are the needs at BBC. And with all these questions, we will, so I just have a graph after, we are based on long graph for that. We will be able, let's say, to have several search in parallel that take care about different entities. And for each entities, we will have correct document. And at the end, the agent will decide, okay, I have enough information, yes, no, it's no. I will come back to ask question on question, sub question on sub question to get more document. So this is more accurate. The issue is sometimes it can take 30 seconds, sometimes it can take 3 minutes, 4 minutes. But for me, it's better to wait and have a good answer than have a bad answer in 10 seconds. But it can take some time because it will run several times some sub-queries, sub-questions to get the right answer. So this is good, but what about if I have a data warehouse with petaoctet of data? I will not index all my data bricks, all my snowflakes, all my redshift inside Hymalaia. So for that, we have another way, again, is to do what we call text to SQL. So that means at the beginning, the user ask a question, and what we will have on the RAG, on the top, what we will index is not the data, it's the metadata. So that means all the column name, relationship between tables, all the technical details that define the structure of the database. We can also add some spreadsheet, some Word document, some information, let's say some business glossary, some mapping between a technical word and a business word to help, let's say, to have the knowledge about how I structure my data and how the users, what is the vocabulary of the user. So that at the beginning, we take automatically the metadata. The user can also upload in the RAG some glossary, some metadata information. And when we have a question from the user, what we'll do is to generate a SQL question, a SQL query based on the metadata on the business glossary. When you do that, so sometimes it's for sure it's to answer complex question with a dozen of tables. So the SQL query is quite big, and sometimes or very often, let's say, the LLM miss a quote, miss and miss something. So you get an error. It's quite common. So what we did is create a system of agents based on the React pattern. The React is reasoning and acting, and it's what you see on the bottom. So that means when you send a query to the database, if the query is not valid, you will get a SQL error. So it's row number 7. And we will go on number 8 on the bottom with the SQL generated plus the SQL error message. And we'll ask the LLM, okay, you generate this SQL, you have this error, regenerate the SQL to correct it. And sometimes we need 2 iterations, 3 iterations to get the right query. But let's say very often after 2 iterations it works. But not at the first time. So it's also a system that so the user have nothing to do. It's just behind the scene. He will regenerate a SQL based on the error to have the correct SQL. So to sum up for the RAG to retrieve information, we see so there is a classic RAG. For me, poor accuracy and let's say it cannot work on production to poor accuracy. The hybrid RAG, when you add several algorithms, when we do both lexical and semantic search, more complex, let's say, to create, but you can manage large document bases, and it can work well. And if you have very complex questions from the user on several entities, what will work is the agent mode with, let's say, most costly, it's slower response time, but it can do, with these multi-step queries, it can answer most of the question. And when you have a data warehouse with petaoctet of data, solution is clearly the text-to-SQL. So it's limited to structured data, but it worked very well with data warehouse. And to finish, with the RAG, we have the understanding. So we answer with precision, context, and traceability. And with the MCP, we can add action, meaning running API on your CRM, on your ERP, and doing some action. For example, update the opportunity on Salesforce, or send an email, or update the ERP. So RAG plus MCP. With that, you have a complex system, let's say, to create agent. RAG is the brain, and MCP are his hand. Thank you, and you can meet us at our booth R2 at the end.